Hi friends, welcome back. Let me explain you Knapsack Dynamic Programming problem. So imagine yourself as a thief. You have a stamina to carry 50 kgs on your own. So you are entering a home. It has 10 kgs, 20 kgs and 30 kg bags lying over there. So in the 10 kgs you have 60 coins, 20 kgs you have 100 coins, and in 30 kgs bag you have 120 coins. You have to come out of the home with maximum number of coins. Okay. So these are the possible options. You can come out of the home with 10 kg bags carrying only 60 coins. You can come with 20 kg bag carrying only 100 coins. You can come out of home with 30 kg bag carrying only 120 coins. But the question is, you have to come with maximum number of coins. So you have an option to come out with combinations. You can pick 10 kg and 20 kg bag, which is whose sum is 30 kgs. So you have stamina to carry 50 kgs. So when you carry 10 kgs and 20 kgs, so carrying 10 kgs gets 60 coins, carrying 20 kg bag gets you 100 coins. Okay, another option is carrying 10 kg and 30 kg bag. So it will give you 180 coins. You can come with 20 and 30 kg bags, it will give you 220 coins. And you can't come with 10 kg, 20 kg and 30 kg bag because your stamina is limited to 50 kgs only. You can't carry beyond 50 kgs. So you can't carry this combination 10 kgs plus 20 kgs plus 30 kgs. So the answer is this one. So that you have to come out with 20 kgs and 30 kgs back so that you will get maximum number of coins, which is 220. Okay. So let's evaluate what are the options left. So here let's consider you have one more bag, okay, which is 100 kgs and it has 220 coins. So but your capacity is only 50 kgs. Here you are given with 4 bags and 4 values and your capacity is 50 kgs, but the last bag, which is 100 kgs, you can't hold that 100 kgs bag because your stamina is 50 kgs. So what do? You just ignore this bag. Okay, so you will try to find how many 10 kg, 20 kg and 30 kgs. So what is the possible combination within this subgroup you will try to find. So you are going to ignore this 100 kgs. Okay, so this is the first option. Second option, within this subgroup, so you can hold 30 kgs back. What do? Okay, you carry this one or you don't carry this one. Only two simple options are left. You either pick this 30 kgs bag and put 120 coins in your pocket, or you don't pick this 30 kgs bag and you try to find the answer within this subgroup. Okay, so whenever you pick 30 kgs bag, you have 120 coins in your pocket and your capacity will reduce to 20 kgs because your stamina is only to hold 50 kgs. You have already picked up 30 kgs bag. Okay, so 50 minus 30, 20. Still you can carry only 20 kgs. Okay, you got it? So there are two options. You either pick 30 kgs bag or you don't pick 30 kgs bag. So let's write a recursive function. Int knapsack int, I'm just passing the index of the, so I'm of the weight array. So how many values present in the weight is equal to number of values present in the value array also. If weight has 4 elements, value will have 4 elements. So I'm going to pass the index of the weight array. From the last I'm going to come. Either I'm going to pick 30 or I'm going to drop 30. Either I am going to pick 20 or I am going to drop 20, like that. So int capacity of the thief. Now as I mentioned you, if I am going to pass the index of the weight array, so index will be 2, 0, 1, 2. Okay, so if weight of index weight of index means here it is 30. Let's say it is 90. So you can't carry 90 kgs. You have a limit till 50 only. So if weight of index is greater than your capacity, what you are going to do? Try to find the answer from return from here. Try to find the answer from the next subgroup. Okay. So you are not picking the bag. Still you have the same capacity to hold 50 kgs. Okay. This is option 1. Now int option 2. What is the second option? Okay. You don't pick that bag. Right. You don't pick that bag. So when you don't pick that bag, you move on to another index minus 1. Okay, when you don't pick up, so let's rewrite this to 30. Okay, you are not picking 30 kgs bag. Still you don't have any bag in your hands, so still you can carry 50 kgs, right? Capacity, still the capacity won't change. Okay, next option 3. What is the option 3? You pick 30 kgs bag. So when you pick 30 kgs bag, you will have 120 coins in your pocket. So add the answer, add that. You have 120 coins plus try to find other values. Okay, you have picked this bag. Now you try to find 20 kgs bag available within this subgroup, right? You're going to decrease the index and you're going to decrease the capacity also. Capacity minus, so this capacity is 30. So you're going to weight of, one second, weight of index. Okay, let me write value of index. You have 120 plus you find the remaining bag from this subgroup. Okay, capacity minus, so your capacity is 50. Now you are holding 30 kgs bag, so your capacity reduced to 20. Capacity minus weight of index, which is 20. Okay, so you get the answer. Option, if you don't pick this 30 kgs bag and from this subgroup, you will get one option. If you pick this 30 kgs bag and from this subgroup, again you will get one more option. You have to return the highest one. Return max of option 2 comma option 3. Okay, let's define one as defined for max a greater than b, question mark, ternary operator I am using. If a greater than b, return a, else return b. Okay, this will return maximum answer. So we have forgot to write the base conditions. If we forget to write the base condition, stack overflow occurs. So the base condition is if the index, I am giving here index as 2. If the index is less than 0, so it's a false. Okay, we can't return anything. If the index is less than 0, okay, array starts from 0 only. If index is less than 0, then we return 0, right? If index is less than 0, we return 0. And if capacity is also 0, if thief can't hold any item, okay, he can't hold even 1 kg, okay, his capacity is 0. So in that case, if capacity is 0, in that case also answer will be 0. Okay, now try to print the answer. Now try to find it. So index is 2. We have 2 items and the capacity is W, which is 50. Okay, let's see the answer. 220 is the answer. So thief came out with 220 coins. Understood? So what happens if we try to increase this weights, and if we increase this entire array? Okay, overlapping subproblems will occur. Okay, so whenever you value of weight, overlapping subproblems will occur and the recursion goes into infinite loop, and it will take a lot of time to calculate the answer. So I have increased the weight array to 30 bags. Okay, this has 30 elements and the value has 30 elements, and the capacity to carry is 340. So this is the way you calculate the number of elements in the array. Size of the entire array divided by first element. So the size of entire array gives one answer, and when you divide it with the first element, it will give you the entire array size. Here the entire weight array, how many elements are there, is given by this formula. So now when you try to give the entire thing to knapsack recursive function, it won't calculate the answer. So it will take a lot of time. Okay, it will go into infinite loop because overlapping subproblems. Okay, how do we solve this? Using caching. Let's break and let's write that cache. So here the capacity is 340. The capacity value is 340, right? So in the question I mentioned W won't be greater than or equal to 500. Okay, and here index, so number of weights here in this entire array won't be greater than or equal to 50. I mentioned that in the question. So index won't be greater than 50 and capacity won't be greater than 500. As there are two varying variables, we define 2D cache. So index won't be greater than 50, right? So 51 we will declare, and capacity won't be greater than 500. 501 we declare. So 2D cache we declared, and we are going to init cache. Okay, for int I is equal to 0, I less than 51, I plus plus. For int j is equal to 0, j less than 501, j plus plus. Cache of I of j is equal to -1. This is the standard thing that we are doing, and we are going to init the cache before calling the recursive function. And what we have to do, so store the answer before returning. What we do, store that particular state answer. So whatever we are solving, that answer is stored in the cache. Next time if it is asking you to solve for that answer, for that state, you check in the cache. If it is not equal to -1, you return it from the cache instead of calling the recursive function again. Now if we try to debug, we will get the answer in few milliseconds. Okay, see, so this is the answer, 1740. So the thief will be having 1740 coins. Understood? Same way, what we do, we just evaluate the number of options present here. We pick the bag or we don't pick the bag. Here we are not picking the bag, so we are moving to next bag. We picked the bag, so we will have number of coins also. So we have that number of coins, and we are subtracting the weight from the capacity. So if the capacity is weight of the index is more than the capacity, we are checking in the subsequent index for the answer. Okay, so out of these two, we pick up the maximum option and we are returning it. Okay, we implemented the cache, we defined the cache, and we are implementing the cache. You can find the entire program link in the video description. Okay, catch you in the next video.